No, but seriously, welcome to this talk on Java apps. We are going serverless, we're going into the cloud, we're going with MicroProfile, Quarkus, and Cloud Run. If someone feels the urge to say buzzword bingo, feel free. But here we are, going for the next 45 minutes, we're going to go through the entire process. As you can see here, we have some business logic, we want to put that business logic into production.
And this is kind of a thing that people, all of us do, because, probably let's admit that we write code for fun, we do. But it's not the only reason to do that. You really want to make something available for someone somewhere. And this is the idea of it. You start with a little bit of code, and then you go to production and go to, by production we mean make it available to someone, somehow, for your users, whoever they are.
Yeah, and the two of us standing on the stage here going to get right through the entire journey is me. I'm Opheim. I'm a developer from Norway, mainly working on Java and Kotlin. I work in a consultancy company called Computas.
And my name is Rustam. I'm a Java champion and Google Developer Expert for Cloud. I work together with Mats, and today I am a little bit undercover. So, this is today's T-shirt. So we would like to talk to you about how you can use the code, how you can do all the way, your journey all the way to production. And it's going to be a kind of opinionated talk because we had to choose some products, we had to choose some libraries, we had to choose a platform to run it, but we'll try to give you a bit of a background and ideas how you can use that knowledge to deploy to another cloud provider, to deploy to another product, another framework, whatever that might be. So let's get started.
Let's get started. And let's get started with our application. So we have to have some business logic, right? We have some business logic in every application. So our application for the showcase today is rather simple. You run it, it gives you two random words. One adjective, one noun. That's it. Which you can use for multi-factor authentication in Norway. We do that. Or you could do it for the name of Docker containers or whatever.
You probably have seen it as a service. When you create new containers, it will give you this. On the next slide, you will actually see what's happening. So if you call a URL, you will see two words. It will be a noun and an adjective. Yeah. And if you click again, you will have a different set. So logic is pretty simple, right? You have a list of adjectives, list of nouns. You pick something at random, you put them together, you return to the user.
Yeah. So, which is perfectly fine, right? So that's where you start. You start by, oh, I have an idea. I have some application, some logic I need to create. Because in the end, we have something we want to present for our end users. And of course, we wanted to do something. And here's the Java code. It's a bit over-engineered with a feature flag and some printing and so on. But essentially, it's just random with a noun and an adjective. This is the business logic we want to be able to present to our users at the end of the day.
So yeah, this is on purpose very simple. Well, it's kind of over-engineered to be doing what it's doing, but it's very simple. It is what? 1, 2, 3, 4 technically lines of code, right? So the point is, you have this piece of code. There is nothing running it. There is nothing being able to start that piece of code. So what you would normally do, how would you make it available? Well, if you want to run it on your local machine, maybe you just want to do public static void main. That works, I guess. But if you notice the URL on top of the screen where we showed an example, we made a few assumptions, right? We did actually, as you can see there, it says localhost, so we're actually assuming it's going to be on a URL. And we're also assuming that it's going to be returning JSON-ish something, so a kind of specific format, right? Right, how do we do that? So slapping on main really doesn't help because, well, it's going to run, but it's not going to be on URL. It's not going to return JSON out of the box. You have to write all that by hand, and it's going to be available just for you. And you don't really want to do that. You want to make it available for your users.
Yeah. But luckily, so that's step number 2 is taking that logic into something that can run for someone else. And there is one there's one solution. There are several solutions, but like the solutions we're going to talk about and which we have chosen for this talk is based on Jakarta EE and MicroProfile, which is like a set of specifications that can help you with this.
So quick raise of hands. MicroProfile, anyone? Nice, very
cool.
good. It is getting better and better, and it's really nice to see. Jakarta EE, just to check your hands are working? Yes, good, okay. Perfect.
Okay, so for those of you who are not really familiar with Jakarta EE, Ivar Grimstad has a great talk afterwards. You should go and listen to him and get to know more about it. But let's take you through like what is MicroProfile, which is like, so there are several answers to this. One answer is to say it's like, this is the official answer, it's like open source community specification and like for enterprise Java. And the important things to say from this slide is that, well, it's a specification and community. I think that's like the two important
So it's important to remember, it is a specification. So it's not an implementation, but it is a specification. It's up to the providers of the runtime to actually implement that and make it available in their products, whatever that might be. So that's one thing. The other thing is also probably just to mention Jakarta EE. If you don't know what it is, you probably have heard of Java EE or J2EE, or it's different names for the same thing. And this is the rebranded new version after it was donated to Eclipse Foundation. So this is basically the old enterprise thing with a lot of new improvements, with a lot of new development and stuff like that. So, but that's the same timeline or, the branch or whatever, call it whatever you want, but the development is the same. Yeah.
And like the easy way to say it about MicroProfile, if you know Jakarta EE, is that MicroProfile is Jakarta EE for microservices.
So originally, MicroProfile started when Jakarta EE was still Java EE, and there was no development happening there. So that was as a kind of reaction. We need to create an opinionated package to create microservices. So that's why this was the old explanation of that it's Java EE for microservices, Jakarta EE for microservices and stuff like that. Nowadays, it's not the correct description anymore, but it gives you an idea because it has a set of things, set of packages that we'll be seeing very, very soon, which makes it possible to create microservices like JAX-RS and health and a bunch of other things. We'll see very, very soon.
Yeah, so like, the saying that all models are wrong, but some models are useful. We could say that about the statement as well. This is a wrong statement, but it's a statement that kind of makes, at least it made me understand better what MicroProfile actually was about. So let's dive a bit more into it, and this is like, we could do an entire talk just on this slide. Yeah. That would be fun, we should do that sometimes, but like, you can see every box here, and every blue box in like the MicroProfile 5.0 rectangle here is a specification, and MicroProfile is the combination of all of these specifications. So you can see that there are lots of specifications. Some of them, those to the bottom, you can see they are prefixed with Jakarta, like Jakarta CDI, Jakarta JAX-RS, Jakarta JSON-B, and so on. And those are the same standards that are in Jakarta EE. So like if you know how to do dependency injection with Jakarta EE, if you know how to do your REST endpoints with Jakarta EE, it's the same standards like that are part of MicroProfile, because these are things you typically need in a microservice. And also you can see that, well, these are some of the standards from Jakarta EE, but not far from all of them. And why is that? Well, that's because of the reasons we just spoke about, right? Jakarta MicroProfile is opinionated as well. So it says, here's the standard for doing REST endpoints. You have no way of doing, there's no JAX-VS, for instance, for web services and so on. So
and also, as you can see, the bottom thing is Jakarta something. And also, as you can see on top there, it says December 7th, 21. That was when the release of 5.0 was. 6 is just around the corner, so it should be coming out very, very soon. And then the picture will be looking a little bit different. So all of those Jakarta things will be kind of put into one box called Jakarta
Core Profile.
Yeah, I was Forgot the word core. That's what happens when you're on the stage. But, so core profile will be put together into one box, and then you'll have the other things. So it has some Jakarta things, but it also has some things that are not part of the Jakarta specification, but still are necessary to create a proper cloud-native applications. Because if you deploy your microservice or your application on Kubernetes, you need health, you need readiness probes and liveness probes, and you need all those kind of things. And this is the additional things that MicroProfile brings to the table as well.
Yeah, and like for those of you who went to Anna's talk earlier today about distributed tracing, you can see open tracing on the top corner here. That will be replaced with OpenTelemetry in the upcoming version. The release candidate is out for MicroProfile 6.0 right now, so it should be just a matter of weeks, I guess. It's right around the corner. And
probably one more thing we need to mention on this slide is this thing that you see on the right side for you there, standalone outside umbrella things. And those are specifications that are there, but you do not need to implement all that to claim to be MicroProfile compatible. So those are inside, but they're also bringing some cool things like reactive programming, GraphQL, all those kind of things that are interesting and nice to have, but you don't have to implement all of those to claim you are compatible.
Yeah, and there are lots of things lots of discussions going on in the community about what's the path forward for these specifications. Will they become part of the MicroProfile core, or will it not? So there are lots of discussions, but we don't have time to go into them. But
yeah. And in case you wonder why all of them are blue, meaning that they're updated, it's because of the namespace thing. So it was actually the change from Java X to Jakarta namespaces in that version. Usually it's a bit more colorful set of things. Some are yellow, some are blue, some are light blue, things like that.
Yeah, all right. So let's move forward. Okay. So as MicroProfile is a part of Eclipse, the Eclipse Foundation umbrella, there's a working group for every Eclipse thing. And you can see that the members of the working group there are big companies, huge companies like IBM, Red Hat, Oracle. But you can also see that there are user groups here. You have the Garden State JUG, you have Atlanta JUG, and you have iJUG, which is a German.
It's kind of the umbrella JUG for Germany, if you haven't heard about them as well. But the point is, there is working group members are quite diverse. Big companies, small companies, JUGs, and so on, so on, so on.
Yeah.
All right.
Okay, so
why?
Yeah, so we are talking a lot about what it is. Now, why do we prefer MicroProfile? Well, the ambition for this entire talk is we want to write our logic. We want to do as little plumbing, boilerplate, the generic technical stuff. We don't want to do that much of that. So let someone else, let's say the runtime, handle that for us. And
we've learned at the keynote today that we need to ask why 3 times, right?
Yeah.
So that's the first one.
That's the first one, okay.
All right. Second why? Well, it's lightweight, because there is a lot of rumors that, it's not even rumors, it's basically false statements saying oh, Java is heavy, Java is big footprint, Java is slow, whatever, all those things that people say that are not correct. And this one is lightweight, and that's one of the reasons why you don't find all the other packages from Jakarta EE in this one, because, well, it's going to be, you minimize the footprint, you just don't pull all the other things that you don't really need to pull into your application.
Yeah.
And that's the second why.
Yeah. Yeah, and the third one, interchangeable. So we said that MicroProfile is a specification, right? And it's a specification that is implemented by several runtimes. So you can start out with one runtime or app server, if you prefer that naming, and figure out that, well, due to something like technical requirements, judicial requirements, anything else, I want to switch to another app server. You can perfectly fine do that without touching your code at all. Of course, you have to touch configuration, POM files, and that kind of thing, but your Java code can be exactly the same.
And we had to do that, especially in the beginning, while this thing was getting stabilized. So early development stages, early versions. Sometimes there would be bugs in implementation. Sometimes you would get weird errors from a runtime. And then you just okay, well, REST client is failing miserably on this one. Fine, we'll just pull it up and then change the POM file and throw it onto, I don't know, just randomly picking one of those implementations, Open Liberty, or Tom EE, or something else. And it's like, oh, it works. So it's really nice. You don't really need to be able to interchange, but it's a nice feature, and it also shows that it is a standard that's supported by others, by several others.
Yep. So,
and speaking of several others, that's them.
Here's like the current list of implementations. Yeah. And this is like, well, you shouldn't use Thorntail, that's deprecated, but they're like, you can see there are several runtimes here. You have like Open Liberty from IBM, you have Cumulus EE from Cumulus, you have Helidon from Oracle, Wildfly Quarkus from Red Hat.
So in case you wonder why Thorntail is still there and why the current implementation of Red Hat is missing, it's just because, again, this slide is from the official 5.0 slide deck, and it's still there because that was a year ago. The slides are not been updated for the version 6 yet because it's not been released, but the picture here will be changing a tiny little bit because then you'll have Wildfly and Quarkus, and a lot of things of Wildfly and Quarkus are based on the small RAI implementations that will be here, and Thorntail will be going away. But all those three are kind of Red Hat's babies, so they will be kind of moving a little bit around.
Yeah. So now we have presented to you that, well, there are lots of specifications, there are lots of implementations. What do I do? Where do I start? And there are several possible answers to that as well. First answer, which should be the right answer, it's like you head to the MicroProfile starter. So like if some of you have been using like Spring Initializer or Quarkus Initializer or anything like that, this is like the MicroProfile umbrella version of that. So like you can go here and like you can choose, okay, what is my Java version? Okay, which version of MicroProfile do I want to use? Okay, which runtime do I want to use? And then you can download the starter for that, which works fine for some versions and some runtimes. But what we have seen is like this implementation is lacking a bit behind, so that you might not get the most updated version. So it can be nice to have a look into have a look at some of the examples and so on. But if you don't find what you're looking for here, you might do the other one.
And there are quite a few of them to choose from. So this is just a bunch of examples. So Quarkus has one, which is lets you create a project for many, many, many things that Quarkus is using. And MicroProfile is one of them, as you can see on the screen there. Then there is Open Liberty, there is Helidon, but there are a bunch of others. But then the thing is, a lot of those starters are like many other things that we'll be showing you on in this presentation on the screen is open source. So if there is something lacking in the starter for MicroProfile, you might just go find the repo and submit a pull request. Just, Yeah.
Or even raise an issue.
Like, yes, or raise an issue, at least raise an issue, but maybe you want to fix it as well. That's really, really nice and relatively, I would say, easy-ish way to contribute to open source.
Yeah, and very much welcome. It's also worth adding. Okay, so now we told you how to start with MicroProfile, what it is, and so on. So now you know where to get started, and we've spoken about the business logic. So now it works on my machine. Now what?
We ship your machine, right? No. Well, probably not. Not a good idea. It's all about making things reproducible. It's all about making things reliable, and you can actually reproducible in two ways. It's reproducible builds, and it's also reproducible deployments. How do you do that? In good old days, when I started, like my first job, my first years working as a professional was, you would develop something, you create a WAR or jar or something, you would, test it on your local machine, then you would go and put that onto a login remote desktop to a server somewhere with a Tomcat installation on it. You would drop off your WAR files there, and you would kind of stand there crossing fingers and hoping for the best. But now we can do better. So you can probably guess what will be the next thing. It's kind of obvious step, but it's an important thing to create a proper cloud-native applications as well. So enter containers.
Yeah. Containerize it, right? That's the short version.
Well, true. So put it in a container, because when it's in a container, you know that you will be able to, most likely without any pain, deploy it. But you also know that you will be, without much pain, you will be able to build those containers on different machines, as long as, well, there are some limitations. You should probably have same hardware architecture, things like that. But in most of the cases, you can create containers, push it to the registry, and know that you can pull it, and it will be behaving in the same way.
Yeah, and like Docker, Podman, CRI, or whatever.
Yes.
Whatever floats your boat. Yeah.
Whatever floats your
Yeah.
way.
So like most of the app servers provide you with a Docker file when you download the starter from the vendor's website, right? Then you get like a POM file, some example code, typically also a Docker file, which may or may not be useful for your project. So it's a good starting point. What we have found during our work is that, well, the Docker files typically don't fit the development process we want, where we like, as a developer, I want to write my code, test it and so on, then I do git push, git commit, git push, and then I want everything else to be done automatically until my code is in production, right? And the Docker files that are currently provided typically don't give that much support for that kind of work. So we have found that we need to do that part ourselves.
And here are just some pointers that you need to think about. This is not to talk about containers. This is not to talk about like best practices, but we're still mentioning that because so you just need to think about things like that. Multi-stage builds to make your containers slimmer. Don't put too much into it. There are many reasons for not doing that. There is obviously one reason is size. The other thing is the footprint. Also security-wise, you don't really want to have you want to have as little things as possible in it, and so on, so on, so on. So there are many, many reasons for doing that. And then, slim-based images, so again, minimizing the footprint, memory, security, all those. Using layers, so, for example, things like you can build things as fat jars, but fat jars contain everything. So every time you deploy a new version of application, it will create a whole new layer or a whole new container. But if you do slim jars, for instance, then you can use the layer technology to actually just replace tiny little bits of your container and make it much, much, much smaller and deploy and all those things. So I'm just mentioning all that so you can just have a little bit of idea what to look for, what to think about, and then think about those things like slim, thin jars, fat jars, all those ways of creating packaged applications.
Yep.
So now we have containerized it, right? The next thing would be, because you remember we want to make this code available for everyone. And how do you want to make it available to everyone? Of course, you can put it on a server and put it on the internet, but you want to minimize, like Matt said, you want to push your code and don't touch it again. You don't want to do as much management as you would otherwise if you're running it on-prem. So then the idea is to put it into cloud.
Yeah. So after you do git push, right, something needs to happen in order to take your source code and transform it into something that can run somewhere in a container. And of course, that's the build server, or the build pipeline, whatever you want to call it. But the automated build part is of course important. And you can do that with several tools, right? You can use things like Jenkins, GitHub Actions. You can do Azure DevOps. Or as we have done for this talk, Google Cloud Build, which you can see a screenshot from on the screen here.
We've used Google Cloud to deploy things. You could use any other cloud. And usually any cloud provider supports several ways of building things. So usually there would be one that is built in, call it proprietary version, which in this case is Cloud Build. It's just their own product. And then it would support other things like, I don't know, Jenkins or GitHub Actions or whatever, which is more like supporting several platforms, several things. Choose the one you like. Choose the one that works for you. We ended up here because it was kind of the easiest. It was just like a few clicks, a few config files, and it was there. But then, again, we used here things that we probably shouldn't use in production. That's a thing called ClickOps. you should not do that. You should probably script that up with Terraform or Pulumi or something like that and actually create a proper deployment script or code or, depending on what it is. But for this example, we're just, because this is not an important step, but the point is automate, automate, and automate. When you think you automated enough, automate a little bit more. Because it will make your life so much easier. It will make your enjoyment factor, call it whatever you want, as a developer, also higher as well.
Yeah, like I think one thing worth mentioning on the screenshot is you can see the part where it says build on push, right? So whenever I do git push to GitHub, Cloud Build picks up that one and starts a new build without me having to do anything. It's really comfortable. But yeah, as Rustam said, you can do this in several ways, right? And also Cloud Build lets you configure your builds, like how do you want your builds to be done in 2 ways. You can use the Docker file, which we already talked about. And for many cases, that's perfectly fine. And if you can go with Dockerfile without having to do some more, say, specific configuration, do that, because that's less complexity. But if you have to do something specific, like, for instance, run your builds with more memory, if you are doing native, typically, Google Cloud lets you use a cloudbuild.yaml file, which is pretty similar to like a GitHub Actions YAML file or a Jenkins file, or all these are pretty much the same, right? But, OK, so now we have built this container image in the cloud. So now, what do we do now, Rustam?
Yeah, so we've written code. We know how to run it. We know what to add to make it, to make all this, call it sugar or whatever on top, where you can do URLs, REST, all that. We've containerized it. We put it in cloud. We automated all that. And what do we do now? Well, I mean, there is one thing that is missing, and that thing is serverless, because you really want to automate the management of your service as well. Well, I mean, serverless is a weird name. It's not without servers. You need servers anyway, like it or not. But it's managed less, or in actually meaning of less, not gone, but less. You still have to do a little bit of that, but it will be less than running your own Tomcat on your Linux, Solaris, Windows, whatever server.
Yeah, so I like to think of it as, well, the service, less of my problem.
Yeah. Oh, that's a good one. That's nice. OK, so how do we do that? There is a way of doing that on different platforms, and serverless also means different things. Serverless can mean serverless functions. They're called sometimes cloud functions, sometimes lambdas, sometimes something else. The idea is it's a tiny little piece of code that can be run at short periods of time. They are not really long-running processes, but they are just, they just run, do whatever they have to do real quick, and then they die. And then next time something invokes them with a HTTP request or some other kind of request, they wake up, they die. Here, you don't want to do that. Here, you want to have actually a long-running application available for your users. So we do a kind of different serverless. So we're running something called Cloud Run. Again, we're on GCP, so this is what it is. The other cloud providers has different solutions for that as well. If you want to go open source, you can also do Knative, which is a layer on top of, so you have Kubernetes at the bottom, then you have some kind of service mesh. Traditionally, it was Istio. Now it's different ones that are supported in Istio, and the others than Istio. And then on top of that, you have Knative, where you just deploy your application. It scales up and down and does all these magic things without you needing to think about that as well. So that's the open source version of that. This is managed version of that. So here you can, but then the cool thing is when you have this thing, you can do a lot of things out of the box. You can do traffic splitting, for instance, right? You can do, we're going to release a new version. We don't know how it's going to behave in production. We'll do 5% of the traffic to the new version, 95% traffic to the old version. We're just going to test it a little bit, see the logs, see how it behaves. So you can do all those kind of things out of the box, typically with a serverless platform that has a mesh and all these things on top of that. It's not a specific thing. Well, of course, you can do it here in the cloud as well, but this is the whole idea of those kind of solutions that has this service mesh thing. And also a lot of security stuff and sidecars and all the fun things.
Yeah.
But the point is, you want to deploy it, and it brings a few limitations. We'll get back to those limitations in a second, but it also brings a lot of positive things. You can scale up and down. Remember, now your application is actually supporting all those health and liveness, readiness, all those things. So you can actually tracing and all that. So you can actually automatically report all that to whatever logging application you have. If you're using cloud, you're using something that is cloud providers provide you with. If you're using something locally, you probably have a product to aggregate all the logs and contain all that information as well. But the thing is, you get all that all of a sudden out of the box for free in a way. You still have to develop it, obviously. You still have to set it up and do things, but you don't have to write it from scratch.
Yeah, and I guess it's also worth saying that about MicroProfile is that it was created to be run in the cloud. So like things like the health service, which Rustam talked about, and the metrics, the tracing part of MicroProfile, all of these fit perfectly well into all this kind of basically Kubernetes-based applications, right? So it fits perfectly well with Cloud Run. So here we are, and now I think we actually, aren't we done, in a sense, that now we have something running in production. Yep. Whenever we invoke the endpoint, which is publicly available, except like we took down the URL some time ago, so it's not working anymore, but like, yeah. Now we have done everything. It's available in the cloud, so we run it, we get breezy backup, and
and it works, right? Then you would just kind of think, well, okay, we're done. Thanks for coming. We're done. But there are a few things that we need to think about because, yes, when you should not go serverless, or it's not only just positive things that serverless brings. Okay, you don't have to manage. Okay, you can do all this traffic magic. You can do all the authentication magic. All this magic things. Cool. What's the downside? Well, the downside number one is actually the same as the positive, like upside. It is scaling up and down. So technically, it can scale to 0, and then when somebody comes in, it will scale up to 1, 2, 3, many thousand, whatever. What does it mean? Well, it means that your application should be actually quick enough to be able to respond in time. Yeah. It also means you should not store state in your application in the memory, because if your application or your container is getting killed and then duplicated to 100 different ones, it's going to be very, very confusing if you have the state in there. Well, it's not going to work. Yeah.
So don't do things like InfiniSpan across 100 instances of some serverless things. That's like not a good idea. It's not a suitable solution for that problem, right? But and the container may be killed anytime, right? Anytime the user is done with whatever happened and no one else is using your application anymore, Kubernetes or Knative would shut it down.
What you can expect very often is that many of those products will let you define minimum number of instances running and all these kind of things, but that's fine. But still, you still have the problem of cold starts if you have it. And that is a thing that we need to talk a little bit more about. So let's talk a little bit about that. So making it fast.
Yeah. So we need our applications to start really quickly. We needed to be ready to accept traffic really quickly, right? Because we can run, even if we run like one instance all the time, if you suddenly get like 1 million users at a certain point of time, then you need to scale up the application, right? And then it suddenly starts up like, I don't know, say 100 instances. And they need to start really fast, be able to take traffic really fast. And several runtimes are great at different things, right? There are lots of these runtimes. Each of them have their own weaknesses and their own strengths. One that has strength in the sense that it starts really fast is Quarkus. From that. So with Quarkus, the entire intention behind it is like, okay, we are creating this runtime to be run inside a container. That means that lots of these dynamic things we are used to with Jakarta EE runtimes are not really applicable anymore. when we are running inside a Docker container, like this entire scanning of new beans, for instance, you know at build time what beans are going to be there, and you can optimize for that, and that is what Red Hat has done with Quarkus. So you can migrate to Quarkus. Okay, we should go pretty fast on this, but like,
yes.
Okay, so when switching from another app server to Quarkus, you download the starter, you have a look, you look through the README, you look through the POM files and so on, you copy the relevant things from the POM files, you copy the Docker file, the properties, and then you're done. You don't touch your Java code at all, or Kotlin code for that instance.
And the cool thing is that you can still, can create a container that's containing all that thing inside. And you can, again, deploy that on a serverless platform. It's because it is a container, it has an entry point, and it has some kind of thing that it returns. So serverless platform is happy, but you can actually put Quarkus and things like that onto it. And that's actually starting to get quite fun. You can actually even create Quarkus, small Quarkus applications even for functions. But that's a different story. So we're not going to go there. We're talking about more long-running processes, but you can.
Yeah. There's so many things we could have talked about.
Oh, there's a lot of things.
So here we are with Quarkus. We'll switch into Quarkus, as you can clearly see from the URL. Right? It says random Quarkus. Never trust us, we have Quarkus running underneath here. And then you get the lighted exclusive. Voila. OK, so that is great. Quarkus starts fast. But I, as a user, I am not patient at all. I'm really impatient. And like, I want the response from the app server, from the application to be like this, right? I don't want to wait at all.
Yeah, because like startup times of, I don't know, say 5 seconds, it doesn't sound much. But for you as a user, waiting for 5 seconds, that feels like an eternity. Because, there is a lot of things that has to happen in the background, right? You have to pull your container from a registry. You have to deploy it. You have to start up a VM. You have to start up that code. Container has to start. Your application has to start. A lot of things that has to happen. So it's kind of impressive that happens in a few milliseconds or whatever, but you can go faster.
Yeah, and you can go faster by going native. So Quarkus has 2 modes. It can run inside the JVM, say as usual, or you can compile it into a native binary and then run that native binary as a container. And that makes that the consequences of that is that your build takes longer time, like several minutes longer time. But whenever you invoke the app server, like you invoke your application, it starts instantly. So the startup time is really, really short. So like if you want to do, say, a serverless Java or Kotlin application as a backend for your front end, you could perfectly fine do that serverless with Quarkus native. It's fast enough that that's not an issue. But that means, so it might be suitable. In many applications, we have found it to be great, but that also means, hopefully your code works with all, not all libraries work with Quarkus native or anything else native, anything GraalVM, say, but many do, and if they do, it starts really fast. But like, it also depends, like how many pushes do you have to commit to production a day, right? If you have lots of pushes and you build the code a lot, then it might not be suitable. So it's a trade-off, but it's certainly an option you should have in your toolkit.
But the thing is, your users will not see that build thing. That build thing is happening on the backstage, on the back office. And it doesn't matter if it takes 1 day to build it or 5 seconds to build it for a user. User cares about the startup times. And so you probably will need a little bit beefier build machine. You probably take a little bit longer time, but that's fine because you're actually using that time that is kind of asynchronous, but then you are still getting much faster response times from cold starts of your application.
Yeah, and like if you want to go from JVM mode into native mode, you don't have to change your Java or Kotlin code at all. You have to change your POM file and your Docker file, and that's it. And if you want to, then we are real fast, then we're done. So, but everything we're speaking about is on GitHub. And what I wanted to point out right now is that the link on the bottom here says Quarkus multistage. So if you want to go Quarkus native, head over to that link, have a look at the Docker file, where I put some effort into like creating a good proper Docker file for native Quarkus.
To optimize your build, to make it a bit more less footprint, less requiring less hardware, and so on, so on, so on. So.
Yeah, and also you can see like all the code we've been showing pieces of, or like hinting towards. It's on GitHub. You can see on the upper links here. It says MicroProfile random strings.
So we have one more slide left, and that's pretty much it. And we'll do the questions afterwards. And that is a slide with our contact information. So just so you feel free to ping us. This is us on Twitter. We will be here whole rest of the day, so feel free to come over and ask any questions. I think the time is up, so I think we'll say thank you very much for coming, and have a nice rest of the conference.
Thank you, everyone.